On this special episode, we look back at 1 year of serverless chats. This is Serverless Chats, episode number 53. Hi everyone, I'm Jeremy Daly, and this is Serverless Chats. This week we're going to do something a little bit different and hopefully kind of special. We're going to go back and we're going to look at the last year of serverless chats. And I cannot believe it has already been a year. We've done 52 episodes of this show. We've had some amazing guests on. The information that they have shared with all of us, I know I've learned a ton from it. I hope that you've learned a ton from it. And I wanted to go back to some of these episodes and pick out a few of the moments that I thought were really, really interesting, that really resonated with me, and I thought was just a really cool concept about serverless, or something that that people need to know about serverless. So obviously we can't go back and look at every episode. There's just way too many of them. But I did try to pick out a few of these moments that I thought were really interesting. So there's a lot to get to. So I don't want to talk too long, and I want to let the guests speak for themselves. So I will introduce each guest and just kind of give you the question that I sort of asked them and why I was asking them those questions. But let's get started. So let's start at the very beginning, episode number 1, Alex Debris. I asked him what he thought about serverless best practices and then the reality of implementing them.
I think it's pretty fascinating to see, like you say, if you're on Twitter and you're following a lot of the big time people doing serverless architectures in this space, they have a lot of great tips around best practices and this is what you should be doing, all that stuff. But I find, as I'm building serverless applications, or as I'm talking to customers and users that are building serverless applications, there are times when there's tension, I think, between what the best practices are and what their circumstances are. And this could be because maybe they're not coming in with a greenfield application, or maybe they have a data model that doesn't fit Dynamodb or something like that. And it's difficult on how you sort of square that with recommending something that isn't the best practice or the most pure serverless application, but you also got to help people ship products, right? So I think balancing that tension can be tough at times.
So there are all kinds of debates when it comes to best practices. And one of the best practices was to not have lambdas call other lambdas. But there was 2 episodes I did with Michael Hart, episodes 18 and episodes 19, where we talked about when some of those best practices break down, specifically lambdas calling lambdas.
There's nothing special about Lambda in this respect. It's like this is just sort of best practices if you were calling any API, or if you were writing any API, that if you're waiting for many seconds, then you might want to deal with that. And those are the sorts of use cases where I think okay, fine, that's perhaps not a good practice. You asked me, we use this at Bustle. So we have a Lambda that does that renders our front end HTML code. It's a Preact app. It does server side rendering of the HTML that it delivers to the to the browser via API gateway and a CDN and things like that. But it calls our other Lambda directly, which is our GraphQL backend. It calls that to pull in the data that it needs to render the HTML page. Now, in the browser, it also will call that GraphQL backend, but it'll do it via API gateway. Because it's coming from the browser, so it needs to make an unauthenticated HTTP request into the function. But when you're in the Lambda world, well, that Lambda can just call that Lambda directly, and call the GraphQL Lambda, and that goes to Redis and Elasticsearch and wherever it needs to pull the data and send it back. And we just make sure we have the timeouts tuned such that it responds within milliseconds anyway. It's not even a thing we've really run into.
So in episode number 2, I had a really good conversation with Nitin Shapira, and we were talking about automating the instrumentation of your Lambda functions. And he had some pretty interesting insights to that.
By the way, it's not just worrying. It's also, it's not just the fact that you can forget. It's also just going to take you a certain amount of time always that you're gonna basically waste instead of writing your own business software. So even if you do remember to do it every time, it's still gonna take you some time. So some ways that can work is, of course, embed it in your standard libraries that you work with. So if you have a library that is commonly used to communicate between services, you want to embed that tracing information or extra information there, so it will always be there. So this will kind of automate a lot of the work for you. So that's just a matter of what type of tool do you use. So if you use X-Ray, you're still going to have to do some kind of manual work, and it's fine at first. The problem is when you suddenly grow from 100 functions to 1,000 functions. That's where you're going to be probably a little bit annoyed or even lost because it's going to be just a lot of work and it doesn't seem like something that really scales. That's where, I mean, anything manual doesn't really scale. This is why you use serverless, because you don't want to scale servers manually.
So another thing that's becoming very popular in the AWS ecosystem is AppSync, especially when it comes to building serverless applications. And so I had a conversation way back in episode number 3 with Marcia Vilchalba, and we were talking about this idea of microservices and then connecting them with GraphQL using AppSync. And there were some questions about the data ownership.
Then is the question on who owns the data, and that's something, at least with AppSync, I'm still trying to figure out how to really architect my application, my GraphQL applications, because I've been using GraphQL with microservices, and usually I do the filtering in the microservice because the microservice knows the data, knows who can see it, and I don't want to leak that information out. But with AppSync, at least the applications I have building, they are mostly contained into Dynamodb tables and lambdas. So I think when I'm coding this, that AppSync is the owner of this data. And then I do the filtering in the resolvers. So I think it's always a question of who owns the data and who is able, where is the level that you want to leak the information out.
So on episode number 4, I had a conversation with Chase Douglas, and we were talking about serverless development workflows. And some of these things have gotten better since then. There's been some new tools, but Chase had some thoughts on the complexity of that development workflow.
Yeah, for all the benefits you get from serverless with its auto scaling and its capabilities of scaling down to 0, which reduces developer cost, you do have some things that you have to manage that are a little different than before. One of the key things is if I've got like a compute resource, like a Lambda function, in the cloud that has a set of permissions that it's granted, and it has some mechanism for locating the external services like SQSQ or an SNS topic or an S3 bucket. So it has these two things that it needs to be able to function, the permissions and locations. So the challenge that people often hit very early on in serverless development is if I'm writing software on my laptop and I want to test it without having to go through a full deployment cycle, which may take a few minutes to deploy the latest code change, even if it's a one-character change, up to the cloud service provider, how can I actually test with proper permissions and proper service discovery location mechanisms from my laptop? What mechanisms are there to do that?
So last year, right around the time that this podcast was starting, AWS launched a new service called EventBridge. And this introduces a whole new way, or at least an easier way in which we can build event-driven architectures. So I have a whole bunch of guests that spoke to this. But let's start with Mike Deck on episode number 5, where I was asking him to just explain what event-driven architecture was.
So yeah, so I mean, I think that it's probably easiest to understand it when contrasted against kind of a command-driven architecture, which I think is what we're mostly sort of used to. So this idea that I've got some set of APIs that I go out and call, and I kind of issue commands there, right? So I maybe have like an order service, so I'm calling create order, or I've got downstream from that, there's some invoicing service now. So the order service goes out and calls that and says, create the invoice, please. So that's kind of the standard command-oriented model that you typically see with API-driven architectures. An event-driven architecture is kind of instead of creating specific directed commands, you're simply publishing these events that talk about facts that have happened. Change, these are signals that state has changed within the application. So the order service may publish an event that says, hey, an order was created. And now it's up to the other downstream services they can observe that event and then do the piece of the process that they're responsible for at that point. So it's kind of a subtle difference, but it's really powerful once you really start kind of taking this further down the road in terms of the ability to decouple your services from one another, right? So when you've got a lot of services that need to interact with a number of other ones, you end up kind of with a lot of knowledge about all of those downstream services getting consolidated into each one of your other kind of microservices. And that leads to more coupling. It makes it more brittle. There's more friction as you're trying to change those things. So that's a huge kind of benefit that you get from moving to this event-driven kind of architecture. And then in terms of kind of the relationship to serverless, obviously with services like AWS Lambda, that is a fundamentally event-driven service. It's about being able to run code in response to events. So when you move to more of this model of, hey, I'm just going to kind of publish information about what happened, then it's super easy to now add on additional kind of custom business logic with Lambda functions that can subscribe to those various different events and kind of provide you with this ability to build serverless applications really easily.
So Mike was getting to this idea of asynchronous patterns for communication between microservices. And this is something that I asked James Bezic about on episode 30 and asked him how he felt about developers embracing this new way of thinking.
A lot of what we're building makes distributed computing just easier for developers. And when you think about the scale that lots of developers now have to face for their applications, even with things like mobile apps, these are complicated problems to solve when you get spiky workloads and there's huge numbers of transactions coming through. So a lot of these tools just make it that much easier. But the mental hurdle is going from this synchronous model to this asynchronous model. And so if you're used to building synchronous APIs, initially it can seem a bit alien trying to figure out the different patterns that are being involved. But it seems like the natural evolution, given the fact that you've got all of these services in the middle that have to handle all this traffic, and the timing issues involved, start to evolve from where you are in the synchronous space. But I think that what's been put in place is not too difficult to understand. And once developers start using this, they find actually for many cases, it's the right way to go. But it's interesting to watch this because I know that just even 12 months ago, people were talking about, with API Gateway, there's this 29-second, 30-second limit problem.
Mm-hmm.
You've got to do all this stuff throughout your infrastructure. Or you heard about the Lambda limits of 5 minutes, then 15 minutes, because people are trying to work this way. And I think now we're going back to thinking about, well, how do we break up these tasks? So it's shorter lived tasks that run between services in an asynchronous fashion. So the whole model is really evolving.
Another thing that asynchronous patterns open up for us is the ability for us to delay processing of data, and there's a really good reason for that. And on episode number 40, I had Eric Johnson and Alan Tan on talking about HTTP APIs, but Eric got into this idea of storage first, and I'll let him explain.
The most dangerous part of an application that I'll ever build is my code, right? So when I build an application, I want to get that data stored first. That's the thing. And if it's in, I tend to go Dynamodb because that's what I like. That's what I use. But there's different purposes. I know, Jeremy, you and I have had this conversation before, and you're an SQS guy. So that's where you tend to go. So and we do this because we look at, okay, what's the pattern for UNO, for like the retry or the DLQ or different things like that. And for me, it's because I'm going to continually write back to Dynamo on the app. I'm specifically thinking about it. But the idea is, if API Gateway can directly integrate with the storage, be it S3, be it DynamoDB, something like that, then I've stored the data and I don't have to go back to the customer if my logic fails, right? So in an application, I've stored the data. Let's say I'm using DynamoDB. I do a stream. It triggers a Lambda. I start processing that data. If somewhere in there something breaks, and again, it's going to be my code, but let's say something breaks, then I don't have to go back to the customer and say, hey, guess what? I blew it. Can you give me your data again? Can you resubmit that and continue to trust me, because I'm sure I won't lose it again. Instead, I've got that data stored and I can write in some retry or take advantage of the retry from an SQS or an SNS or something like that. And so I think it's a really cool pattern for building resilience into our application. Serverless comes with a lot of resilience anyway.
Mm-hmm.
I mean, that's how AWS has approached this on, look, as much as we'd like to say nothing ever breaks, let's write as if it does, right? And so let's degrade gracefully. And I think this adds even another layer of that, where I can degrade in my code and know, hey, I've still got the data. I can write some retry logic. I can use existing retry logic. I think it's a safer pattern. So, and it does require, the storage first is the pattern, I call it, but it requires thinking asynchronously. What can I do after I've responded to the client? And how do I work with them?
So even though there are a lot of tools that AWS is building for developers to help build event-driven and asynchronous applications, I spoke with Paul Swale on episode number 41, and he gave us a couple of things that developers need to think about when they start to build these asynchronous applications.
There are a few things. So number one, I would say distributed tracing. So if you have a multi-step use case where there's a lot of data processing going on in the background, you probably now have multiple log files to search through. So there are that if you were doing that synchronously, you could just look in the one place more often than not. So there are strategies around using correlation IDs within each message, so that say in CloudWatch you can query on for that correlation ID and get an aggregate of any log entries across your different log groups which have that correlation ID within it. But you need to build that into your application, your Lambda code. That doesn't come out of the box. Another consideration is testing, or writing automated tests. It's just harder for asynchronous workflows. So if you're writing a synchronous, say I write in Node.js and Jest test framework.
Mm-hmm.
So if I have a synchronous Lambda, it's generally pretty easy to write an integration test for that. You just hit the endpoint or invoke the Lambda function or whatever, and just verify the response. But if you have a multi-step multi-step asynchronous data processing workflow, then you need to test each one of those individually. Doing an actual writing an end-to-end test is difficult without just like having wait a step which just waits until background processes have completed, and then you can do whatever verification steps you need. And just generally understandability. It's not a thing in itself, but if you've got a new developer on your team, and a lot of teams that I've worked with are sort of more like a full stack web developers, but which are used to monolithic sort of synchronous workflows. Mm-hmm. They're get a new guy on your team, and just explaining to them how each piece of the pie fits together. That's just going to take time, and documentation really is the only solution to that. So it's just good documentation is important when you've got these asynchronous workflows.
Paul mentioned this idea of distributed tracing, and on episode number 8, I spoke with Rand Ribbensaft on why it's so important.
Up until recently, like 2 or 3 years, I would say that distributed tracing is not a mandatory thing that each R&D team need to have as part of his arsenal of tools. Today, I think it's almost like a crucial or vital thing that you need to have. The main reason is that we already know that application becoming more and more distributed. So for example, once user is buying something at your store, you want to make sure that it gets the email to him with the receipt and the invoice and so on as soon as possible, because otherwise he's hanging there waiting for a confirmation or waiting for something to get to him. And in a monolithic way, it's been pretty easy because you had something specific, a single thing that would take care for everything. But now we've got like between 3 to 300 services that might take care for this operation. One that will get the API request from the user from the web server, the other one that will parse the user request. The third one might be something regarding billing that will charge him through Stripe or through other service. The fourth one can be something that is mailing users. And all of them are connected to each other with some messages that running from one to another. It can be like a star, or it can be like one-to-one all the way up until it gets to the email service. And without distributed tracing, you wouldn't be able to ask yourself this question: how long it takes to a user once he buys something until the moment he gets his confirmation? Because if it takes, let's say, for example, a ridiculous number, let's say 1 minute, it's not good. I don't want my user to wait one minute in my website for confirmation. I want it to be, let's say, sub-second, or let's say sub-5 seconds. Other than that, it doesn't meet my SLA. And only with distributed tracing, I can really measure end-to-end traces and not just a single trace every time.
So distributed tracing now gives us a bunch of insight into the different pieces and the interconnectivity of our application, which is great. So when something goes wrong, we need to know whether or not it needs to be escalated and somebody has to deal with it. So that is a little bit different in serverless. And when I spoke with Emre Shamdan on episode number 12, he explained when we should actually take action and when we should let the cloud handle it for us.
Most of the tools that both with CloudWatch and with the other monitoring tools, the alerts are just for a single error. So you are just having a one Lambda invocation, an error happens, and most of the time they are paging an alert. But we thought that is this something that is actually wanted by people? Is that something that prevents people from alert fatigue? We are coming from Opsgenie, and that's why we are very, very careful about not putting people into alert fatigue. So we ask people, what is the definition of failure for you? Like we asked like maybe tens of people of what do you think about when do you think that this serverless architecture is failed? And the response is that like not a single error, like single errors most of the time is not an error. So when I cause something an incident, when it causes something cascading failures. So I have a problem with Lambda function, and this Lambda function should have been trigger another Lambda function through SNS, and this triggers another Lambda function through, let's say, SQS. Like I'm just throwing out a scenario here. And so this first Lambda function fails, and the others even couldn't start. So in this case, we can understand that we are in a very bad trouble, that we lose some transaction there. And this is something that is a failure for most of our people that we talk with. And the other stuff is that for at least, especially for upper management, the invocation duration, invocation count, any kind of abnormality about these metrics are not very important. And they are seeing cost as a signal of failure. So when let's say when they want to allocate $10 per day into their serverless architecture, and let's say $1 per function, in such cases, they want to get alerted when the cost exceeds this threshold. They are not interested in if the function is running more than expected because of a third-party API. They are not interested in if the problem happens because of an input error. They just wanted to see if the cost is exceeding some threshold, because all of their motivation was, when starting with Lambda, to save cost, and they don't want to ruin that with an problematic situation.
Emre mentioned this idea of monitoring costs within your serverless applications. And this is because serverless applications are elastic, and if you have more traffic, you're going to pay more money for those services. And so on episode number 6, I spoke with Eric Peterson, and I asked him about this variable costs and whether or not this is a problem versus something more steady that maybe the higher ups in the company would be used to.
There is that tension there. I mean, sometimes it's a healthy tension, but but there is that tension there, and it kind of, I mean, it goes like this. Imagine you needed to explain, let's say, a very complicated system that you constructed, and now you're trying to explain it in French to the Germans, right? It's you're speaking a different language, and that's the hard part, right? You get asked the question, well, why did we spend $20,000 this month on EC2 more than we spent last month, for example, right? And you go, well, it's because the product team had a new initiative. We had to do a migration. We had to do this. We had to move data from over here. We had security requirements, so we needed to encrypt the data. So we're calling the KMS API a lot, and then that resulted in a whole bunch of new storage and processing. And you go and you're talking, and then you look up, and it's just a glazed over look on the finance guy's eyes, and they're going, yeah, no. Why did we spend $20,000 more this month, and how much are we going to spend next month? And they go, what? I can't talk to you. Get out of here, right? Ultimately, you want to tie it back to, well, look, this product initiative costs this much money, and we forecast it to be X, and we have an idea before we actually go down that path of how much it's going to cost, and cost has been a part of it because for a long time in engineering, there's been a notion of non-functional requirements, right? What kind of performance requirements do you have? What kind of uptime requirements do you have? And the hard question that I think organizations need to ask themselves is, well, what kind of cost or budget requirements do you have? And at what point are you going to compromise the budget for the user's experience, or vice versa, right? Are you going to go, what? The user experience matters at all costs. Even if it's $1 million in extra spend this month, our users must be absolutely happy. Okay, make that decision consciously. Today, I don't think anybody's consciously making that decision.
Something that's been really fascinating to me is this idea of resilient architectures, right? Just this idea that we can build applications and systems that can absorb failure as opposed to just shut down everything. And so on episode number 9, I spoke with Gunnar Grosch about some of the things, though, that were missing from the application side of this.
One common thing that I see when we're performing these types of experiments is that, like we said before, we don't have graceful degradation, so that the systems, they show error messages to the end users, or they parts just don't work but are still there. So we don't have UIs that are non-blocking, and that's a perfect use case for chaos engineering to be able to find those and then fix them.
So there are a ton of ways in which we can build resiliency into our applications. And on episode 51, I spoke with Adrian Hornsby, and we talked about caching and whether or not there was an acceptable level of staleness even for real-time data.
Well, even if you claim your application is very dynamic and you claim that, hey, no, I can't cache because, for example, it's a top 10 list of real-time trends on Twitter. Let's say Twitter trends, right? People expect that it's real-time. So I would say by default, if you think about real-time, people wouldn't think, okay, I need to cache that. But hey, if you have millions of clients around the world requesting that data, absolutely you want to fake it real time. You might query your downstream server or service that tells you the trend, but maybe if you have thousands of clients connecting at the same time, you don't want each of those clients to query your service, and you will just serve it from cache, right? Or make sure that the requests are packed into one single request, and then ask the downstream service, and then serve back the content. So it's just this idea, like any application out there, even if you think it should be or must be real time, it's very important to think about the stallness. And stallness is like how real time my data needs to be, or even if it's maybe 3 seconds old, is it really that old, or is it not usable? Because it's also something you can fall back, so if your database is not accessible, it's like maybe you can serve back the trend of Twitter that was maybe an hour ago, and just instead of, and you can say to your customer, you say, oh, we're experiencing issue. This is the trend 1 hour ago.
Mm-hmm.
And that's fine. Yeah. It's a good UI. It's a good use of stored data. And why would customers say, oh, you're cheating on us? No, it's like, I think it's a good example of that.
Another thing that comes up a lot on the show is the idea of testing. Specifically, how much local testing do you want to do? On episode number 10, I spoke with Slobodan Stojanovic about what he does for building local tests and how he would actually test his entire application.
So in the early days, when I started working with serverless, I tried to just do the things that I did with non-serverless applications. So my first try was like to install Dynamodb locally and use it as a local database and test against it and things like that. But then there were so many different services, such as like Cognito or SNS or many other things that I cannot just install locally. So there are some things that can simulate them, but these are simulations. You don't want to run your tests against simulations because they will not give you the right results. And then the second, my second try was basically to mock these things. So I tried to find some complex mocking libraries and things like that will mock everything and return the realistic results and things like that. And even that is like leading to so many errors, and some things are not mocked. You have some special things in your code, or you are using the old library, so you need to send some pull requests and who knows what. So these things become more and more complex. And in the end, we just decided not to do that. Instead, we want to run our tests locally, unit tests mostly. And whenever we want to test, to run integration tests, I want to test my code against real DynamoDB, which is on AWS, or real SNS, or real services that are on AWS and that are working in the cloud.
And speaking of integration tests, on episode number 47, I spoke with Mike Roberts, and he explained not only the value of integration tests, but what exactly you should be testing with them.
And what integration tests are about are testing your assumptions effectively. So when I talked before about functional tests, I said, so we're going to mock or stub the response that comes back from DynamoDB and make sure that we're doing the right thing with that. That makes an assumption that we've correctly defined what comes back from DynamoDB. And so what integration tests do is validate those assumptions. They validate how you expect your code to run within the larger environment and the larger platform. And we absolutely advocate for doing that, but remembering that running and maintaining integration tests is a costly exercise. They take a long time to run, and they also take a long time to maintain because things change over time. And so, we put a lot of work into the integration test section of the book, and John did this extraordinary thing with Maven, and those of you that are Java developers will understand this, but where we run Maven test, which is one command line. And what that does is it brings up an entirely new stack of all of the components in our application, runs all the integration tests against it. And then if the tests work, then it immediately tears that stack down. That's, we wouldn't have gone into that amount of effort to get that stuff working if we didn't think integration tests were valuable. But we also understand that because they're expensive, both in terms of our time and computer time, that we want to minimize the number of those that we write. And so we're looking normally at just a few that capture hopefully a number of cases. But again, we're not testing the code when we're writing integration tests. We're testing our assumptions about the larger environment. If we want to test the code, that's why when you write a unit test or a functional test.
Serverless is extremely secure right out of the box, but there are still things that developers need to do when it comes to application security. So in episode number 11, I spoke with Hillel Solo and asked him if it would just be easier to use tools that helped with runtime protection.
Yeah, so my number one cliche would be, let's focus less on mitigation and more on prevention. And I know that's, that's super cliche in security, but I think here, one of the things that we see a lot is that you get a lot more mileage out of trying to make sure that the things you're deploying are deployed with least risk. than you do at trying to chase after attacks. And again, that's not to say we don't need to do both. We will forever need to do both. No amount of proper configuration and hygiene is going to prevent every type of injection attack or cross-site scripting attack or whatever it is on our infrastructure, right? We need to mitigate all those things. But in cloud applications, and particularly in serverless cloud applications, the value of hygiene and posture is much greater than it was in the past. Whether it's the things we talked about earlier, like just leaving around old stuff that could put you at risk but you don't need, or it's getting IAM roles configured properly, or it's things like setting timeouts to their minimum threshold if you can. All those things are going to give you a tremendous amount of value in making it hard for attackers to do what they want to do on your system before you even started looking for SQL injection, right? You still need to look for SQL injection. We still need to run the tools that we're going to run. But before we get there, before you start worrying about blocking and mitigating kind of runtime attacks, spend a significant amount of energy on what do I have? Where is it? Do I need it? Is it configured in a way that gives me the least risk? Have I isolated the things I can isolate? Am I doing all that continually? That would be my number one focus.
A lot of research has been done into serverless security and identifying the possible attack vectors that could potentially compromise a serverless application. And on episode number 23 and number 24, I spoke with Ori Segal about the legitimacy of these serverless security threats.
But you have to remember that as security practitioners and specifically as researchers, we are trying to flag potential future risks. If we were to only look at what's being used and exploited today, we will always be in a dog chase with attackers. So I think it's very good that security experts and security researchers look for the next attacks in a new technology and finding it before it's being exploited. And so you can then teach developers how to avoid these and hopefully reduce the attack surface. So I think it's not necessarily bad that we're pointing out things that haven't been exploited yet. And as you mentioned, regarding the evidence, usually attackers, there aren't web forums where attackers share war stories of how they hacked into a system. So obviously attackers don't publish anything about their techniques. And especially if you talk to application owners and companies, most of them also don't like to share information. In fact, usually when I give the serverless security conference talk, at the end there's that 5 minutes that you keep you say for questions. Usually I know that nobody's going to actually ask a serious technical question because they are embarrassed. It's like something that you don't want to talk about around other people from maybe competing organizations. So it's not, there's no resource to go and look at and see how people are exploiting and what are the vulnerabilities. We collected information from customers and prospects. I've reviewed dozens, if not hundreds of serverless apps at this point. And we collected this information to see what are the most repeated risks that people do.
If you've ever listened to this show, you know that I am a huge fan of Dynamodb. And on episode number 17, I spoke with Brian LaRue, and he explained why they chose Dynamodb as the default database for the Architect framework.
Yeah, I mean, it's a decision-making process, and it's one that a lot of people aren't comfortable with. It's a managed database, which is a nice way of saying that. It's a proprietary database. It's owned and run privately by Amazon. And, after our history has our industry has a long history of being gun shy of these databases because of Oracle, frankly. And I don't blame anyone for painting Amazon with that brush. And like, oh, my database, that's my data. I don't want them to have that. I want to control it. The only people that say that, by the way, are people that have never sharded a database. Once you've sharded a database once, you are happy to let someone else manage that for you. You are more than happy. How much does it cost? Fine. It's less than a DBA. So that's going to be a good deal for me. So once you get over that initial concern, which isn't a real concern, by the way, the free tier is extremely generous. You can run a local instance of this thing yourself headlessly if you want for testing and building out locally. So you don't have this requirement of the cloud. And the free tier is insane. I think you get something like 20 gigs in the free tier. So like you can build a lot of app, 20 gigs, a lot of app. You can put images in there, you don't want to, but you could. It's a great DB. I guess the other thing that people get a little tripped up on is the syntax is it's a bit strange. It's
Right.
coming at it from a different world. I don't think it actually is that strange for what it's worth. I'm pretty sure if you'd never seen SQL before and I showed it to you, you'd be like, "Whoa, that's strange." So, like it's just what you're used to. It's a sadly verbose query language. It takes a lot of directives in JSON form to make it
Right.
do pretty trivial things. We've written a few higher level wrappers for it to make it a bit nicer to work with. But it's all about the semantics. Single digit millisecond latency for up to a megabyte at a time querying, no matter how many rows I have. That's unreal. Like we've never
I
had a
know.
database that can do that. And I'm happy to pay for that capability.
There are a ton of good reasons why you should use NoSQL, but on episodes 34 and 35, I spoke with Rick Houlihan, and I asked him when we shouldn't use it.
So NoSQL is really suited, and as we talked about, we have to denormalize the data, right? Which that means I have to structure it and tune it to the access pattern. So if I don't really understand those access patterns, if they're not really well defined, then maybe what we're looking at is a different type of application that's not necessarily so well suited for NoSQL, right? And that's really what it comes down to. There's two types of applications out there. There's an OLTP, or online transaction processing application, which is really built using well-defined access patterns. It's going to have a limited number of queries that are going to execute against the data. They're going to execute very frequently, and we're not going to expect to see any change, or we'll see limited change in this collection of queries over time. And that's a really good application for NoSQL because, as I said, we have to kind of tune the data to the access pattern. So if I only have a small number of access patterns, then it makes sense. But if the customer comes in and tells me, I don't know what questions are going to be asked, this is my, maybe my trading analytics platform, and who knows what the brokers are going to be interested in today or tomorrow. And I look at the query logs of the server, and there's 1,000 different queries, and some of them execute once or twice and never to be seen again, and others execute dozens of times. And these are things that are indicative of an application workload that maybe is not so good for NoSQL, because what we're going to want is a data model that's kind of agnostic to all those access patterns, right? And that has that ad hoc query engine that lets us reproduce those results. So, lucky for us in the NoSQL world, that's actually a small subset of the applications, right? 90% of the applications we build have a very limited number of access patterns. They execute those queries regularly and repeatedly throughout the day. So that's the area that we're going to focus on when we talk about NoSQL.
On episode number 36, I spoke with Supatra Rufo about the adoption of NoSQL databases and why it is becoming so important, especially in enterprises.
Yeah. I think the way that consumers behave, the way that just the retail industry is a good example. So um, you probably didn't know that Sears, Kmart, Barney's New York, Party City, I can name a dozen more retailers that just last year either completely closed down or had to significantly reduce their number of stores just last year. It's because retail isn't done the same way anymore. Those spikes are now a common part of life, and people are having a hard time figuring out how to handle it. Tesco, which is the largest grocery chain store, um, I'm not sure in America or in the world. I'll have to check that. But they in 2014 crashed on Black Friday because they couldn't handle the spike in the demands that they were getting online. So they lost an entire day of business on Black Friday because they couldn't handle that workload. Um, and then the year later, they went on a NoSQL database, and now they can handle that load. So I think what people are seeing is that normal day-to-day business operations are fundamentally different. For example, the fashion industry used to have only 4 clothing seasons. So, like your mother probably remembers buying a new outfit every season. So, winter, spring, summer, and fall. And so, women's clothers would go and create new clothes 4 times a year. Now, the fashion industry has 52 seasons. So, every week is a different season of
Wow.
women's clothing, which means there's a spike every week for every launch of every new clothing line. So that's another big database problem that is now just becoming a regular part of life. So a decade after NoSQL databases are invented, I think this is now it's really not a new invention anymore. Now this is just the way of business.
I had a really great conversation about big data with Lynn Langett on episode number 39, and I asked her about the adoption of NoSQL in enterprises as well, and she explained why the hybrid approach is probably the better way to do it.
Well, change comes slowly, and change is usually induced by some sort of pain, right? And so the pain in my case, in my customer's case, was through IoT data, because IoT data increased the amount of data exponentially because of the event-based data. So I had some customers, some of the big, like the biggest appliance manufacturer in the United States, and customers I can't name, but you can guess who they are, right? And this was maybe 8 years ago, so it was still a while ago. They wanted to IoT enable their, devices. And so suddenly and again, to be very clear, the majority of the enterprise applications that I would work with would be SQL plus NoSQL.
Yeah.
Because they would have a need for transaction. And again, that's really important because I saw a lot of startups go just directly to NoSQL, and then they would call me and they would try to tune their transactional consistency of their Mongo, and it would be a cluster and it would be a mess. And then we just pull that out and put in MySQL. This, the whole, space was super interesting. So meanwhile, the cloud vendors are evolving, and Amazon, of course, comes with DynamoDB. And I have to tell you that initially I was super resistant. I was like, that's, how do you even query that? And how does that, I actually did some time tests and blogged about, this is like 7-8 years ago, of, you write a SQL query, everybody knows how to do that. You write a Dynamo query, it takes, 15 minutes because you have to research the query and how much is that in your dev time and da-da-da-da-da-da-da. So there was resistance, including me. The service on the cloud that really stunned me, and still does, is BigQuery. Because BigQuery offered SQL querying, which I think it's extremely important when you're evaluating different kinds of database solutions to look at what is the ramp up time to understand how to get data in, how to take data out. And the more different the query languages are, the more errors you're going to have too. And this is your data. So I've seen a lot of bad things where developers overestimated their abilities. And because the query languages were really idiosyncratic or esoteric for the NoSQL databases, it was all kinds of problems.
A common concern with NoSQL and with DynamoDB tends to be this idea that the data model itself is highly inflexible, and that if you make a mistake early on, that it's hard to change access patterns after the fact. Well, in episode number 44, Alex Debris joined me again after he wrote his amazing DynamoDB book, and he explained that there are a number of strategies that you can use to migrate data and make it more flexible than you might think it is.
Yeah, absolutely. And this was actually a late addition to the book, but I just got so many questions about, I don't want to use Dynamo because, what if my access patterns change, or how do I migrate data, things like that. So I actually went through it. I think it's not as bad as you think. And I split migrations into 2 categories, basically. First off, they're just additive migrations, where if you're just adding a new application attribute to existing items, you just change that in your application code. You don't need to change anything in DynamoDB. Or if you're adding a new type of entity that, doesn't have any sort of relational access patterns with an existing entity, or if you can put it into an existing item collection of an existing entity, you don't need to do anything. It's just a purely application code change there. The second type of migration is, I need to do something to existing items, either because I'm changing an access pattern for an existing items, or I'm joining 2 existing items that weren't joined together, or I'm adding a new entity type that I need a relation and there's no existing item collections to use there. So now you not only need to change your application code, but you need to do something with your existing data. And that's harder. It seems scary, but it's actually not that bad. And like, once you've gone through one of these processes, these ETL, migration processes, they're pretty easy. It's basically a 3-step process. You're going to have some giant background job that's going to scan your table. You're going to look for the particular items you need to change. So if it's an order and you need to add, GSI2 PK and GSI2 SK for it, you find your orders in that scan. For each order that you find, then you add these new attributes on them. And then, if there are more pages in your scan, you loop around and do that again. So it's just this giant while loop that operates on your whole table. Depending on how big your table is, it might take a few hours, but it's pretty straightforward, that 3-step process. Scan your table, identify the items you want to change, and change them.
Another common theme that we saw this year was this idea of companies making that transition to serverless. And on episode number 20, I spoke with Sheen Brizzles about how Lego actually developed the confidence to go serverless, not just amongst the developers, but also across the entire company.
Yes, that's a very, very good and important point, because when we often look at a monolith, we often get confused. Where do I make a start? Because it looks everything big. But thing is, we need to start looking more closely, part by part. So then we will be able to identify some small entry point into the system that will give us the comfort to, try out something new. And also, when you work in the organizations, you need to prove or showcase these things to the stakeholders in order to get their buy-in. So for that, it's important that we identify a part of a system that is not complicated, small enough that we can experiment with the new ideas and show the proof that it's working and it's feasible for us to go forward to everyone around, not just the engineering team, bring the business stakeholders, everyone together. And so that's very crucial especially when we start this sort of monolith to microservices serverless journey.
So gaining confidence is important, but it's also about taking existing applications and trying to port them over to a serverless workload. And that's not necessarily an easy thing to do or something that companies are willing to invest in. So we saw some products this year that made it a little bit easier for companies to take those existing applications and give them a little bit of serverlessness. And one of those is Google Cloud Run. So in episode number 22, I spoke with Brett McGowan, and he talked about this sort of hybrid transition from existing workload to serverless containers.
I think one of the messages I want to kind of get across is that maybe moving to something like containers and Cloud Run, it feels like you're taking on way more than like just getting started with functions as a service, right? Your Lambdas, your Azure functions, your cloud functions. And there is a little bit more to manage. I don't think it's a huge amount of overhead, but I think what this really does is it enables a lot of your like existing workloads to start to be serverless, because we all have apps that we started before serverless was a thing, and we would love, even if it's not perfect, we would love to get them to be serverless.
On episode number 15, I spoke with Mark McCann and Jillian Armstrong, and Jillian had some advice for companies that were thinking about adopting serverless.
I tell people, especially in big enterprises, the same for both serverless and AI, which is start now. You're already behind. If you haven't started, you need to start now. It takes a while to learn all the things that Mark's just said, a lot of things. It takes a while to move your mindset from how we architected things before to serverless. Serverless is very different even than microservices. So even if you're very familiar with microservices, this is still a different paradigm. So it just takes a little while to learn. It takes a little while to move all your existing practices and thinking about how you build your systems. So you need to start, you need to find places that are sort of safe to fail places where you can try things out and then gradually scale up. And I think the big thing is if you run the company, do create time for people to learn. Do let them have that space, and find your people who are really, really passionate about it, and then let them loose.
On episode number 32, Ken Collins had some advice for companies as well.
Yeah, I think it's always to look at what your business is doing right now and where you need it to be sort of performant first, right? So always drive by success, right? I'm a very huge believer in DHH, the sort of creator of Rails, that you do the majestic monolith first, you build an application out, and then you sort of look at where it needs to either be performant or broken apart. For Custom Ink, if your story is anything like ours, it would basically be starting with the monolith, looking to where sort of business units lie in that monolith, and then breaking out into what we sort of call key domain services, right? So we would extract the design lab from the monolith. We would extract the product catalog from the monolith. We would extract, a group order form and quoting systems and things like that from the monolith. So that to me is a really good way to sort of adopt the cloud, if you know you're going to be breaking up this monolith into smaller parts, some of them could be Lambda lists, some of them could be, say, Fargate or EC2 instances, whatever. But I think when you look at what's happening with your current application, let your success drive your architecture. And I think Lambda is a good place for either moving apps, but it's also a really good place for, if you're in AWS, to question if that's an opportunity for you to look at doing data and events and units of work in a different way.
As Jillian and Ken both mentioned, adopting serverless in an organization is not only a process, but it has challenges. And so on episode number 33, I asked Yen Trey what some of the biggest roadblocks were for companies that were trying to adopt serverless.
The biggest one, I think, is by far is just education. Like I said, the Lambda itself is getting more and more complicated because of all the different things you can do with it. Other roadblocks include, for example, some organizations are still holding on to the way they are used to operating with centralized operation teams, cloud teams. So teams, the feature teams don't necessarily have the autonomy they need to take full advantage of all these different tools that you get and all this power and agility you get with serverless. Your team can build a new feature in a week, but it's going to take them 3 weeks to get anything they need done, provisioned, and to get access to resources they need. Then again, you're not going to get the full benefit of serverless. So a lot of that legacy thinking at the organization level is still there and still a prominent problem and roadblock for people to take full advantage of serverless. But in terms of actual adoptions, a lot of it is in terms of technical roadblocks. There's some, I think the last question you had was around some use cases that just doesn't fit so well. When you've got a really high throughput system, the cost of serverless can become pretty high.
Right.
So imagine if you've got something that's relatively simple, but have to scale massively, like your Dropbox, not a super complex system, but have to scale to massive extent. So for them, it makes perfect sense to move off of S3 and start to build their own even hardware so that they can start to optimize for that cost. And for a lot of companies, they do have that concern as well. They may not have a very complicated system that requires 100 different functions on this massive event-driven architecture. Yeah. Maybe they just have 5 endpoints, but those 5 endpoints are running at 10, 50,000 requests per second.
Yeah.
So in those cases, the cost for using Lambda and API Gateway would be excruciating.
Yes.
And you'd be much better off paying a team to look after your Kubernetes cluster or your containers cluster than running them on Lambda. But that's always a tricky balance. How much, because oftentimes you can also get a reverse argument whereby, well, Lambda is expensive, so I'm gonna just do my stay myself. But then you're hiring someone for 10 grand a month
exactly
to look after infrastructure, and your Lambda bill is gonna be, I don't know, $100.
By the way, make sure you check out Yen's Real World Serverless podcast. He has some awesome guests on there that talk about how they're implementing serverless in their organization. So awesome content. Make sure you check that out. But the other thing that Yen mentioned in here is education, right? And education and training and certification is a hugely important thing. But just that alone, there are challenges in training people how to use serverless. So in episode number 37, I talked to Peter Sparsky about this.
Look, I hate to use the word paradigm, but it does feel, it is really a paradigm shift because serverless, it feels like this is what cloud was supposed to be all along, right? You're not kind of dealing with low-level infrastructure concerns. You're not provisioning your servers and thinking about memory capacity, but you're thinking at a high level of abstraction. You're thinking in terms of code. You're thinking in terms of functions and services and event-driven architectures. And that's interesting. It's different. And it requires people to really think in new ways. Look, I think honestly, the adoption of serverless will hang on education. Mm-hmm. If we do it right, if we can educate people, serverless as a concept, as an idea, will be successful. And I think that's what we're all working towards. I mean, this is what you do nearly every day, right? You educate people on serverless, you blog, you talk, because this is the way we get people to understand.
So Peter is absolutely right that there is this amazing community of people that are creating content and trying to figure out best practices and so forth for serverless. And on episode 25, I spoke with Farrah Campbell, and I asked her what she thought about the serverless community being more welcoming.
I definitely do. serverless is a new approach. It's inventing a whole new way to build software applications, and it's sticking. And this community, I feel like everybody has a lot of work to do, a lot of big things to accomplish, and everybody's at a starting point. Everybody's willing to have open conversations without putting others down or, explain to you why you're wrong about something. Everybody's at the same starting point and just trying to learn from one another.
So something else we saw a lot of this past year were front-end developers now starting to build back-end components and become this idea of a full-stack serverless developer. And on episode number 28, I spoke with Nader Dabit about this, and I asked him what his thoughts were on this new concept.
We think that what we're doing is a little different than anything that's kind of been out there before, I think. And we don't really have, something to compare it to, but we talk about it in a couple of different ways. One of the things that we talk about is this idea of full stack serverless development, where you're, kind of a developer or you're a team or you're a startup or you're a company, and you want to be able to kind of enable a developer or a team of developers to build the front and the back end versus having the traditional maybe engineering team where you have kind of a back end developer and then you have a front end developer. We're kind of looking at it like, what if a developer could just be looked at as a full stack developer like we've seen forever, but instead of kind of the traditional full stack developer where the back end developer might be in charge of creating servers and creating a database and kind of like patching and dealing with all of the different back-end resources, we could kind of take the serverless philosophy, use that, and then apply the front-end developers and kind of like merge that together and enable a single developer to build out these full-stack apps or a team.
So I personally love the idea of this full-stack serverless developer, and something that's really interesting about what front-end devs can bring to serverless is this mindset of static first versus just serverless first, because static content can be served from the edge. And on episode number 50, I spoke with Guillermo Rauch about this, and he explained why we should be shifting our focus away from computing everything on demand and pre-rendering things.
Yeah, I think a lot of people in the industry have over-focused their attention on computing on demand, which is what Lambda enables, right? You're literally firing up a VM. It's amazing how easy AWS made it. Like, it's almost like a miracle, right? That like you deploy your function so quickly and like it executes so quickly and like it's secure and in a VM sandbox and their underlying technology is absolutely incredible with Firecracker. But the question that you have to take a step back and ask yourself is that, do I really want to be computing so much? Do I want to be burning electricity and like computing cycles so much? And this is where like when we really sat down to analyze this problem, we realized the vast majority of pages that you visit every day on the internet can be computed once and then globally shared and distributed. So it's kind of like the technique of memoization in functional programming, where like you compute once, and then, of course, you want to read from that intrinsic automatic cache that you get. It's different from caching because caching requires a lot of developer effort and thinking. Memoization gets closer to what I envision to be the foundation of serverless frontend, which is basically static generation, where the computation happens once, probably as a result of some data pipeline, something that changes, computation happens, HTML is spit out. That is all, even in the case of Vercel, is powered by functions too, by the way. But the funny thing is that the developer never even thinks about functions. They just think about building pages that then get pushed to the edge and then consumed by visitors. Now, that's not to say that the on-demand use case doesn't have any merit, right? Like, not everything can be computed statically. And like, there's lots of pages where like you sign in to a dashboard and you have to query data that could absolutely not be cached. A great example is like you log into your bank, right? And like, imagine if you were trying to statically generate your dashboard with your like bank account balance, but you just want to check that your payment went through for a utility, and you're not sure like if what you're reading is up to date or not. You would go crazy, right? But the movement of front end has also led us to where that dashboard is a single page application, most likely, that is also served statically from the edge. And then there's JS code that runs on the client side that then queries that backend, right? So what we found is that front end is really powered by this like set of statically computed pages that get downloaded very, very quickly to the device, some of which have data inlined with them. And this is where like the leap of performance and availability just becomes really massive, because you're not going to a server every time you go to your news, your e-commerce, your whatever. You're just downloading it from like your very own city, right? But even in the case of like, I may have to make a strong read, not like a read that could be stale. You're basically also downloading static content that then runs JavaScript on the client, and then that goes to a server, right? And then the question becomes, who's writing that server and how much of that server are you writing? So this is kind of like the other big question that is, I think, coming up. We're confronting that in the serverless world is like, okay, I have all these amazing primitives to build everything in the world that I could imagine from scratch. But does it make sense to build everything from scratch, right? Does it make sense for you to build your own authentication function with Lambda if you could be reusing a standalone authentication service? And that's why this interesting world is coming up, where like there's a rise of the front end, but then there is a rise of the API economy. And what I mean by the API economy is that we have services like Stripe and Twilio and AWS Cognito and Auth0 and Magic Link and like all the services where you're just making some quick API calls, sometimes directly from the client side, right? Yeah. And that is a serverless world that seems so much more, in my mind, attuned with the actual ideal and the actual original promise of serverless. I think we kind of erred too much. You were giving the example of like SQS and Dynamo. We erred too much on always rebuilding from scratch a little bit. So focusing on the front end kind of allows you to like kind of reprogram your product strategy in a way. We're like, okay, I'm going to think about the customer first. I'm going to think about building my backend very, very low in my priority list, right?
On episode number 31, I spoke with Alexander Simovic about how serverless is actually rapidly increasing the capabilities of voice automation services.
Naturally, of course, you can order things from Amazon or whatever, but you're now slowly starting to see, for example, print, give me some report, or send this, or send a message to someone else. And we have even seen the appearance of these echo shows in the past 2 years, where you can even see when something is happening. In front of
it's like a visual interface that's on top of your voice commands.
Exactly. And what my kind of prediction and things I'm working on, I'll talk about it later, is that we're going to come to a point where things are going to be automated using Alexa on like many manual things that we're already doing right now. I don't know, office manager tasks, like, I don't know, send somebody a reminder, or like schedule a meeting. Or we already can see that using Alexa for Business. But all these small pieces are people are starting to discover how can they easily use it. But as serverless evolved, and now people are actually building huge applications on like enterprise scale applications on serverless, and we saw that on reInvent this last year. This is how things are going to evolve with voice as well. So we're going to see an explosion of higher order kind of software, like more complex software. That's, you might have an intelligent agent or an Alexa skill that's going to be able to, do some financial, or maybe do your taxes. You don't know, Yeah. So, things are slowly building, these building blocks are appearing. We see AWS is building this whole serverless ecosystem around itself, where, it's going to be a piece of cake, actually combining these components and creating something out the box.
Serverless can help us build software faster, but it doesn't necessarily mean we're going to build it better. And on episode number 42, I spoke with Susanna Kaiser about using domain-driven design to build better software.
So your domain-driven design comes with a core statement that in order to build better software, we have to align its software design with the business domain, with the business needs and the business strategy. And so domain-driven design helps you with aligning your software design with this business domain and needs and the strategy. And it's very crucial for building your software solution, because otherwise you are building something that, for example, are not matching the requirements of your users. Instead, you have to collaborate with intensively with your domain experts to gain domain knowledge and to understand the business, the problem first before you're solving it. And we are tending to jump directly into solving a problem technically, and we can just let's deploy it on a Kubernetes cluster, but we have not understood the problem first, and that's really crucial to build better software.
Another interesting conversation I had about building good software was with Jared Short on episode number 49. And he talked about pretending that you were building your product so that it could be open sourced at any time.
A lot of companies are building towards, I'd say, short-term right now value versus long-term stability. Right. And that I get that. It makes a lot of sense, especially financially in certain cases. If I need something right now versus, what's this going to look like in 6 months when we circle back to it. But ultimately, building this if you're going to open source at any time, I think forces you to at least think, if somebody was looking over my shoulder right now, right? If I was building something and say, if Jeremy's looking over my shoulder right now, am I really going to put like my GitHub magic key or whatever into this line of like code and just hard code it and like deploy it and be like, I'll fix that later. Like, I feel like Jeremy's going to be back there and be like, really, man? Like, I respected you. And now, no, like there's nothing. So I think it helps you justify the few extra minutes, or in some cases hours or days, to make the right technical decision. And I get tech, that's a thing. Look, go look at open source code. There's tons of stuff out there that's like, to do like actually like make this work appropriately, or optimize this thing. Like, that's fine. Nobody's going to judge you. We all get it. People write software and they understand software is hard. But they are going to judge you pretty hard if you make poor security decisions or poor architectural decisions where it just doesn't make sense. And I think having that fictitious open source, gazer over your shoulder, it just helps you make those decisions and kind of think to yourself.
On episode number 48, I spoke with Linda Nichols about why you should trust cloud services and use them in your serverless applications.
Yeah, absolutely. And I mean, I think in the cloud in general, because, when we were talking about standing on the shoulders of giants before, we were talking about using NPM packages or Ruby gems or whatever. And like, you kind of just don't even know who's written those. And there's some security kind of considerations there. And also like, you just don't know how much they're tested. You don't know if that maintainer is just going to go find another job somewhere. When you're talking about cloud services, and this is true for all the major clouds, I mean, they are tested by millions of people. They are used billions of times. So, I mean, if no one's going to say like, oh, I just, don't think that, fill in the blank service, like Cosmos DB. I just don't think it's really tested that much. Or like, what if the person who works on it leaves? Well, there isn't one person, right? It's a whole team of people, and there's a company that supports it. So, I mean, I think it's kind of ridiculous when people don't trust cloud services. If you don't want lock-in, that's a whole nother discussion, right? But if you're already in a cloud, and I mean, a lot of people are multi-cloud, also, and they kind of spread things around to try to minimize that sort of lock-in feeling. But really, you get locked into libraries too, right? Absolutely. If I'm writing a Node.js app and I'm using some NPM package, that thing's going to stick around forever.
I asked several of my guests what they thought the future of serverless was going to be, what it was going to look like over the course of the next 5 years. And on episode number 7, Taylor Otwell gave his predictions.
Yeah, I think the next 5 years will be huge for serverless. I really do. I think it is the future, because what's the alternative really? Like more complexity, more configuration files, more weird container orchestration stuff, I don't really think that's the future, that people are going to naturally gravitate towards. I think people want simpler things. And I think at the end of the day, serverless is simpler, and it's going to only get more simpler as the tooling gets better, as the platforms get better. And to me, it's the real end game, of the whole server thing. It's just deploying your code, and you focus on your code and let the provider focus on the infrastructure.
On episode number 38, I asked Ben Ellerby the same question.
I think it's going to be more abstraction and more consolidation around how to do things. So in 5 years, it's going to be more abstraction around that configuration. So you're not having to manually configure retry policies. Out of the box, you're sort of being able to maybe not point and click, but in a very short amount of YAML, be able to have an event-driven architecture. And maybe that becomes formalized, an event sourcing service rather than just an event bus. Maybe other areas of event-driven become more formalized. But it's always going to be an increase in abstraction. We went from virtualization to containerization to function as a service and other things as a service. Now we're sort of building more event-driven. We can have abstractions at different levels. So they might be abstractions in particular services or abstraction of the whole architecture. Things like the serverless framework have tried serverless components. AWS has tried the serverless application registry. Now those things have had varying degrees of success, but built into all of these services, although we're getting a bit more, we seem to have had a spike of complexity recently as so much has been announced and so much has been released. I think we're getting more abstraction. If we take the amazing work you did about integrating RDS with Lambda, and you built a whole sort of open source project that really helped people with that. Recently, although there's still a need, AWS has abstracted a lot of that with the RDS proxy. They've seen a need from the community and then abstracted that. If we take EventBridge, people were doing CloudWatch custom events kind of before and hacking it. And then they formalized that and provided a level of abstraction. Now, is that abstraction going to be driven by the cloud provider or by the community? Well, I think it's going to be a bit of both. AWS and other cloud providers are going to add more services, but also increase abstraction as it goes on. And the community is going to build amazing open source projects that increase abstraction. So I think a move to more abstraction, which means less configuration, and configuration is just code. So it means less code to achieve the same business value. So for me, it's more abstraction, but right now it feels like less abstraction.
And finally, on episode number 52, I spoke with Tim Wagner, and I asked him if he thought that serverless needed to embrace statefulness in order to become the default computing paradigm of the future.
I have these two strong reactions to that statement, right? Like one of them is, I would say in some ways, the most successful thing Lambda has done is to challenge thinking, right? To get people to say, do you really need a server stood up, turned on, taking 20 minutes to fire up with, a bazillion libraries on it. And then you have to keep that thing alive and in perfect condition for its entire life cycle in order to get something done in terms of a practical, enterprise application. And challenging that assumption is one of the most exciting, important, and successful things that I think Lambda and other serverless offerings have accomplished in our industry. The flip side to this is, to be useful, sometimes you have to be practical, and right. and it's equally true that you can't walk up to an enterprise and say, all right, step one, let's throw all your stuff away, and then step two, right? Because they're not going to get past step one. Like there is it's funny, we always talk about greenfields, brownfields. It's all brown in the enterprise. There's right. Even if you write a net new Lambda function, it's running against existing storage, existing data, existing APIs, whatever that is, right? Nothing is ever completely de novo. And so I think to be successful and be as adopted as possible in the long run, serverless offerings are going to also have to be flexible. And I think you see this with things like provision capacity. I mean, we had, when I was at Lambda still, we had long, painful debates about, is this the right thing to do? Yeah. Right. and for understandable reasons, because it is less stateless. It took it's obviously optional. We don't force anyone to use it, but by doing it, it makes Lambda look more like a conventional, server container, conventional application approach, because there is this piece that is a little bit stateful now. And I think the art here is for the serverless offerings to not lose their way, to find this kind of middle ground that is useful enough to the enterprises, that still challenges assumptions, that gets people to write stuff in a way that is better than what came before, but doesn't pander completely to just make it feel like a server.
Right.
But is also practical and helps enterprises get their job done, instead of just telling them, because just sermonizing to them is also not the right way to do it.
And that's this year in Serverless Chats. Thank you for listening to these episodes. I hope you enjoyed listening to them as much as I enjoyed making them. And thank you to all of my guests for sharing all of their serverless knowledge. I know that I have learned a ton this past year. I hope that you have learned something as well. I'm looking forward to continuing in the show, talking to new guests, amplifying new voices, learning more about serverless, and continuing on this cloud journey that is always evolving. I hope that you will join me for that as well. If you want to check out the show notes and a transcript of this episode, you can find them at serverlesschats.com/53. For more Serverless Chats, subscribe, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily. And if you want to keep up to date on everything serverless, make sure you subscribe to my Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.